So this is how most people think modern manufacturing works. You have the material, throw it in, press the green button, oh yeah, and it's ready. In reality it doesn't work like that, and especially if you are making a complicated oyster knife design like this. So we're not talking about the blue handled plastic rubbish throwaway knives, we're talking about a real nice full titanium knife. And if we're going to produce that on a CNC machine like this, we're going to need fixturing. And fixturing is like a complete plate decked out with all the positions and a certain way to hold it, because this is a 3-axis mill. It can come in from one side, which means you'll need to flip it around to mill it on the other side, which means it has to be very precise if you flip it around, otherwise the machine is milling around here and the knife is around here. So there are some nuances to it. Set the feet down. Okay, program finished. Let's do the door button. There we have a flat piece of, a on-size piece of aluminium, which we'll use later as the first prototype for the oyster knife. So I buy my aluminium at the moment at Abrams Premium Steel, but they also have aluminium. And it's really flat and it's really shiny. But if you're in Europe, please let me know where you buy your aluminium, because well, I'm quite new to this and haven't got my supply chain on order yet. Program. Let's go for it. I did op-stop, so it stopped after every tool, before every tool change, but I also turned on the wrong coolant hose, so it was spraying everywhere, but not on the tool. It happens. Let's fix it. So I was actually spotting the holes for the drill operation next, and this worked out great. There we have it. So I said I was a novice at this, right? I did 3 operations: spotting, drilling and milling the shoulder for the bolt, for which this fixture is going to be clamped on the main fixture. Only the 6mm end mill if you do the helix down into the pocket. It's not big enough for a small M5 screw like this, so I actually have to set up another tool and retouch it off, and then do little pocket. So yeah, things like this, they cost you half an hour because you make a simple mistake. Next time you'll check and make sure that everything fits. So let's make this little pocket. So here's actually what we've been making today. It's a pocket for the screw so that I can bolt this later on the main fixture. And this is going to be the negative mold, but it worked out. So with the fixture, which is the third up done, and the material, which will be the first up, so it will be in here. Here we will drill 6 holes. Those 6 holes will be placed in here. Here we can screw the knife down. Then we will flip it over into the negative mold here. And the last step will be another negative mold, and then we will remove the 6 steps. So I'm now ready. Well, I should make another negative mold, but I don't have the material for it at the moment. So I'm gonna pull out the vise and put this thing on if I am capable of fixturing it, which is at the moment quite a question because it's actually too large for my table. So either I have to cut a piece off, which is okay, or I don't and have to clamp it somehow. We'll see what happens. So the aluminium plate is now in, and it's beautifully shiny. It's supposed to be very flat. So I just put it down with these toe clamps, and I'm going to drill some holes, and they need to be exactly where my slot is, because then I can clamp it down with T-slots. And I'm going to set up my 12mm tools. So I have here my tool cart with tool holders, and I'll need this one. I need a pull stud. So I'm now ready to start drilling. So I'm going to drill here, 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 and here for T-slots. I want eventually 3 more here, but yeah, this is just way too close to my tool setter and I don't have enough travel on my table. So I'm going to do it with baby steps, and hopefully this goes right. I think that was my first crash. Okay, so it's definitely Monday morning. I know what happened, but I don't know why it happened. So I was using this large drill. It's a 12mm one, and it bumped into, well, the fixture blade, and then the controller immediately said like spindle overload, and it stopped. I luckily had it on 25% rapids. I figured that button out recently, didn't have that the first time. But why? So when I was looking at my Z values, like the absolute value, it was at 160 or something. So I did Y, and then I did G4386, and now it did work. Only I don't know why that didn't work before, because it's in the code. So okay, so maybe it's not so much of a crash, but a stall in the drill, because I'm trying to 12 millimeters in one go, and maybe that's a bit too much. So I'm gonna pre-drill with 5 and maybe try again. I have to look it up, I have to do some googling, but I reviewed the footage as well, and it's not like a really hard crash, but it's just like when it hits, it stalls. So it's Monday morning, right? So, going great again this morning. Now we have multiple alarms for the spindle, and it's stalled once again. So yeah, yesterday was Monday. It was really Monday, because it was the first time the Netherlands got into a real lockdown, which we are today. But the controller is locking me out as well, so don't know what to do at the moment. Okay, so that was actually quite an easy fix, I suppose. What you can see is that the drill is packed with chips, so the chip evacuation wasn't good enough. Probably drilled a bit too deep. So after 2 mornings of, well, messing around and a lot of stress, I finally managed to drill 1, 2, 3, 4 holes. Woo! Okay, so now I'm gonna mill the pockets. Hopefully this works. This, ladies and gentlemen, is called a drill press, and what it does is it drills holes, and when it stops or stalls, I don't get a heart attack, which is nice. I couldn't really figure the drilling the holes out on a CNC. It's 12 millimeters, which is around a ½ inch. Even on the drill press, I find it quite hard. It's something in the speeds and feeds, but the reality is I don't have time for that at the moment, because when you're watching this video later, it's now December 2020, and 2020 was an amazing year full of pandemics, crises, global recession, crash weddings. So yeah, it was an amazing year, but 2020 also had some opportunities. But because of the pandemic, there were a lot of incentives, and I was able to get a government grant to buy the CNC mill to develop my product. So it's not the entire machine, but it's a part of it. But there is a 6-month valid, the voucher is 6 months valid. So 6 months means 4 months from production time and shipping from China, which then means that I have 2 months to complete this Oyster knife. And into the details we'll go later, but for me that now means that it's just better to drill it on a drill press. And because these holes don't need to be precise, it just need to be holes. Drill it on a drill press, be done with it. Then try to improve speeds and feeds and go in a deep dive and buy new end mills or buy new drills or try milling the pockets, stuff like that. That'll come. But I now know what to do, but I'm moving onward and I'm cheating. Not the shiniest, but it's supposed to be flat, so that's something. Okay, so maybe it's now time to show you guys how I actually want to make this knife. So this is the knife, this is the fixture we've been making. The first step is to put a block of titanium or aluminium as we start off in. Here we have some dowel pins, holes, and here we have some microbite clamps. These microbite clamps should press the block to the dowel pins. Why so many dowel pins? I'm only going to use 2, but I'll have tolerances on the material. There is a -0 + 2 millimeter tolerance. So if I put the dowel pin in a different hole, I have to post another code, but then I can use the same material on the fixture. So hop 1 is doing 1, 2, 3, 4, 5, 6 screw holes, because hop 2 is going to use those 6 screw holes, and we're going to mill the top side, then we're going to flip the part over, it's going to lay in a negative mold, and once again we're going to screw those 6 together, and then hop 4 is once again a negative mold, and then we're only removing the tabs. So I'm going to do this operation by operation. I actually made 3 test holes in the bottom to see which program I should run to have a perfect fit dowel pin. Yeah, file, Fixture 12, that's okay. Let's do a quick graph to see what we're actually doing. So here's an actual dowel pin. Let's see if we can press it in. I did a stock to leave. Yeah, it's not fitting yet, which is okay. So I'm gonna do a pocket next to it and see if it then fits. So the good news is it fits perfectly. The bad news is it's rather hard to get out. But I like that for now. It's something I can work with. There are all the holes we're drilling for the slotting pin. And there's the spindle. I'm gonna have to drill 3 holes, M8.5 millimeters for M10 tapping. So the tapping is something I'm really nervous about, but having had problems with drilling a 12 millimeter hole, this is something I'm also very nervous about. So tested the code, do it real slow, and hopefully it works out. Okay, so once again, very exciting, tensioned moment where I have to go and tap an M10 hole. So I watched the video on NYC CNC. I have a flexible tapping head, I have a tap, I have drilled the hole. It's yeah, not much more I can do, I suppose. Well, let's see what happens. Yeah, not a lot. I'll be honest and say that this is not how I want to do it, but I can't get the tapping right for some reason. It's probably because I don't have the correct tap for this kind of hole with a CNC milling machine. The thing is, I don't want to risk it, so I'm just hand tapping, and for the next operation I'll be drilling 18 holes that need to be tapped. It would have been nice on the machine, but I'll hand tap them anyway, just to make sure that we have the holes in place and we can continue this process. Very amateuristic, I'm aware of that, but yeah, it is what it is at the moment. So do you remember the block of the first part of the episode? It goes in like this. There will be another white clamp here, and if I have the correct Allen key, which I do not have because it's some sort of weird imperial Allen key, if I have it, I can bolt it down here, and these will push against the push pins, and then it would be solid, and hopefully then we can machine 6 pockets and 6 holes where we can bolt it down for the next operation. Try to tap all the holes, so these are now all tapped, except this one. the center to last, that was the last one, the center to last one broke my tab. Luckily I broke it down really deep, so I can get some, grab some threads with the bolts. When I'm doing all this machining operation, it will have 6 bolts attached to it, so I hope I won't get any chatter in this corner. But it could have also just have worked, and then we would have been ready. So once again, remember this block from the beginning of this video. Right position. We're gonna bolt that down here. 1, 2, 3, 4, 5, 6, and then machine a negative mold in where we can place up 3. So for the past few days I've been busy with programming the negative mold, which is really difficult because I'm machining the knife on the first 2 ops, and then everything is going smoothly, and sometimes the end mill won't reach a certain corner, but then it will leave a slight radius, which is okay. But now I have to do the negative mold, and there I also have a lot of square corners on the knife that now need to be well, milled, and the mill always leaves a radius, so I think I'm there now. So let's take a look. You can see it starting, right? So this was everything with the 6mm end mill. We're now going to a 3mm end mill, which is about 3/8, and then we should see a lot more details. This is exciting. Longest code so far at 1 hour 48 minutes. And I have to say that looks quite nice, especially this, because these lines are going to be really what sets my knife apart. I think that's really lovely. It's really smooth as well. Really happy with that. So if I put everything on the fixture, I'm now ready to start making that first aluminium prototype of this knife. And that also means that this is the end of this video. I hope you liked it. If so, please subscribe, because then you can see the next video, because we're going further and further in this series till we have a developed Oyster knife. So thanks for watching. I hope you enjoyed it, and hope to see you again next time.